Sound is a longitudinal wave which consists of compressions and rarefactions traveling through a medium. A sound wave can be described completely by five characteristics: wavelength, amplitude, time period, frequency, and velocity. All these characteristics of a sound wave will be described one by one. The minimum distance in which a sound wave repeats itself is called its wavelength. In simple words, it is the length of one complete wave. The wavelength is denoted by the Greek letter lambda. In a sound wave, the combined length of a compression and an adjacent rarefaction is called wavelength. In a sound wave, the distance between the centers of two consecutive compressions or two consecutive rarefactions is also called its wavelength. The SI unit of measuring wavelength is meter. Sometimes, however, centimeter is also used for expressing wavelength. When a wave passes through a medium, the particles of the medium gets displaced temporarily from their original undisturbed positions. The maximum displacement of the particles of the medium from their original undisturbed positions when a wave passes through the medium is called the amplitude of the wave. The term amplitude is in fact used to describe the size of the wave. The SI unit of measurement of amplitude is meter, though sometimes it is also measured in centimeters. It should be noted here that the amplitude of a wave is the same as the amplitude of the vibrating body producing the wave. The time required to produce one complete wave or cycle is called time period of the wave. Now, one complete wave is produced by one full vibration of the vibrating body. So we can say that time period is basically the time taken to complete one vibration. Let us suppose there are two waves which are produced in 1 second. Then the time required to produce one wave will be half a second. In other words, the time period of this wave will be 0.5 seconds. The time period of a wave is denoted by the letter capital T. The unit of measurement of time period is second. The term frequency tells us the rate at which the waves are produced by their source. The number of complete waves or cycles produced in 1 second is called frequency of the wave. Since one complete wave is produced by one full vibration of the vibrating body, so we can also say that the number of vibrations per second is called frequency. If 10 complete waves or vibrations are produced in 1 second, then the frequency of the waves will be 10 Hz or 10 cycles per second. The frequency of a wave is fixed and does not change even when it passes through different substances. The SI unit of frequency is Hertz, which is written as capital H with a small z. It is named after Heinrich Hertz. He was the scientist after whom this frequency called Hertz is named. A vibrating body emitting one wave per second is said to have a frequency of 1 Hertz. In other words, 1 Hertz is equal to 1 vibration per second. Sometimes, however, a bigger unit of frequency called kilohertz is also used. The frequency of a wave is denoted by the letter small f. The tuning forks are often marked with numbers like 256, 384 or 512. These numbers signify the frequency of vibration of the tuning forks. For example, a tuning fork of frequency 256 means that its prongs will make 256 vibrations per second and emit 256 complete sound waves per second when hit on a hard surface. So, by now it should be clear that the frequency of a wave is the same as the frequency of the vibrating body which produces the wave. The relationship that frequency is having with time period is inversely proportional, or we may say frequency f is equal to 1 by capital T, that is time period. The distance traveled by a wave in 1 second is called velocity of the wave, or simply the speed of the wave. The velocity of a wave is represented by the letter v. The SI unit for measuring the velocity of a wave is meters per second. It can be written as m/s. We know velocity is distance traveled by time taken. Suppose a wave travels a distance, say lambda, which is the wavelength, in time t. Then v is equal to lambda by t. Here t is the time taken by one wave. We know that 1 by t becomes the number of waves per second, and this is known as frequency, which is represented by the letter f. So we can write f in place of 1 by t. Thus v is equal to f into lambda, where v is the velocity of the wave, f the frequency, and lambda is the wavelength. Or in other words, we may say velocity of the wave is the product of frequency and wavelength. Thus the velocity or speed of a wave in a medium is equal to the product of its frequency and wavelength. This is known as wave equation. It applies to all types of waves: transverse waves like the water waves, longitudinal waves like the sound waves, and electromagnetic waves like light waves and radio waves. The wave equation has three quantities in it. So, if we know the values of any of these two quantities, then the value of the third quantity can easily be calculated.